Welcome IGCSE students. We are looking at reflectional and rotational symmetry in the first two exercises of chapter 14. I'm going to first begin with a video on reflectional symmetry. Reflectional symmetry, which we often call line symmetry or mirror symmetry, we can recognize it by one half of picture or drawing or shape being a reflection of the other half, and we call the line which we reflect across the mirror line. You can see with this example of a dog here that each feature of the dog is the same distance away from the mirror line. How many lines of symmetry? Well, different shapes have different numbers of lines of symmetry. Some have none, some have more than one. Let's look at triangles, for instance. An equilateral triangle, a regular triangle, it's going to have all of its sides equal and all of its angles equal, and we have 3 lines of symmetry there. An isosceles triangle, where we've got 2 sides equal and 2 angles equal, we only have 1 line of symmetry. And of course the scalene triangle, where there are no sides that are equal and no angles that are equal, then we'll have no lines of symmetry. A folding test, this is one way that you can figure out whether there's a line of symmetry, and we often do this with pieces of paper. Now, rectangles. Sometimes younger students think that if you fold across a diagonal of a rectangle, you're going to have a line of symmetry. But of course, when you do that, you end up with this shape here, and it's not sitting perfectly on top. The edges aren't matching, so we can't really call this a line of symmetry. However, of course, from your making of paper aeroplanes, etc., you'll know that if you fold across a rectangle like this, you do end up with a line of symmetry. So that's line of symmetry. Let's talk about quadrilaterals or 4-sided shapes. With the square, all sides equal, all angles 90 degrees, you have 4 lines of symmetry. Here is a rectangle. You've got opposite sides are equal and all angles are 90 degrees. You end up with 2 lines of symmetry. Here we have an irregular quadrilateral. We have no lines of symmetry in that. A kite will have 1 line of symmetry. And a rhombus will have 2 lines of symmetry. Regular polygons, like a equilateral triangle, a square, and a pentagon. Notice that they all have the same number of lines of symmetry as they have angles or sides. Here's another example. We've got a hexagon. It's going to have 6 lines of symmetry. This is a heptagon. It's regular. It will have 7 lines of symmetry. And an octagon. A regular octagon will have 8 lines of symmetry. So, hopefully, you've figured out the regular polygon pattern. The number of lines of symmetry equals the number of angles or sides in the shape. Now, circles is a special case because you can draw a diameter anywhere on the circle. There are an infinite number of lines of symmetry. You can just keep on cutting in a slightly different position and you'll have another line of symmetry. Let's take a look at rotational symmetry. All 2-dimensional shapes have some rotational symmetry. The degree of rotational symmetry that an object has is known as its order. Here are some examples. For shapes that have order 2 rotational symmetry or higher, a single center of rotation can be located. And I've just popped them in there in red. For shapes that have only order 1 rotational symmetry, they can have a center of rotation anywhere. There's just a few examples there. The order of rotational symmetry that an object has is the number of times that it fits on itself during a full 360-degree rotation. So, that is order 1 because it fits on itself only 1 time in a full rotation. This one fits on itself twice in a full rotation, so we call it order 2. The next example, once, twice, 3 times. This is order 3. And finally, once, twice, 3 times, and 4 times in its full rotation. Just in case you're confused, that white dot, we're just using that to show us where we're up to in our rotation. It's not part of the shape. Okay, so that one's in order 4. Well, what about this one here? What is the order of rotational symmetry? Maybe have a think to yourself before pause the video. Okay, let's try it. Once, twice, 3 times, 4 times, 5 times. So order 5. What about this one? Well, we'll put a dot there and we'll rotate it. Once, twice, 3 times, 4 times, 5 times, and we're back to the beginning again. So 6 times, order 6 rotational symmetry. Now we're going to do some of our well-known shapes. An equilateral triangle, what is its rotational symmetry order? Well, it's going to simply be order 3. Okay, what about a square? Well, it's going to be order 4. As you can see, once, twice. You get the general idea. So this is an order 4. Now we're looking at a rectangle. What rotational symmetry does this have? Once, twice. What about a parallelogram? Once, and back to the beginning again, so this is order 2. What about an isosceles triangle? Once in the whole rotation, so it's order 1. Scalene triangle. Once in a whole rotation, so it is again order 1. What about a trapezium? Isosceles trapezium, what have we got? Once in a whole rotation, so this is order 1. What about just a standard trapezium? Once, so order 1. A kite? Once, so order 1. And an ellipse, like an oval? Once, twice. Which leads us to think about circles. Circles have an infinite number, rotational symmetry, because wherever you turn them, they will fit on themselves. So they're a bit of a special case, infinite order of rotational symmetry. Okay, so you might want to pause the video at this point and just have a quick look through these and see if you can figure out what order of rotational symmetry they are. Number 1, order 6. Number 2, order 2. Number 3, order 3. Number 4, order 2. Number 5, order 1. Number 6, order 3. Number 7, order 2. Number 8, order 5. Number 9, order 4. Number 10, order 1. Number 11, order 6. Number 12, order 8. And now for the next page. You might like to pause the video at this point, figure them out. Number 13, order 4. Number 14, order 1. Number 15, order 2. Number 16, order 5. Number 17, order 2. Number 18, order 4. Number 19, order 6. Number 20, order 3. Number 21, order 5. Number 22, order 4. Number 23, order 3. Number 24, order 1. Well, I hope this video gives you enough information to have a go at 14.1 and 14.2. Good luck, guys.